All right, class, here is a continuation on our work with hyperbolas. So if you watched the first video, this video is going to be a lot easier. If you haven't watched that first video, you really need to go back and look at it because I'm going to talk about these problems in terms of the way that I showed it to you in the previous video. So what I've done is this for us, and I'm just going to show you. I have one problem right here. I have another problem here, and then I have a final problem here. What those problems are exactly is problem 42, problem 46, and problem 52. Each one of those has slightly different instructions to them. In 42, it says sketch a graph of the hyperbola and label the vertices and the foci. So out of this one, we need to sketch a graph of that and somehow label the vertices and the foci on our graph. So we're going to get to that. In this one, 46, it says for the following given information, find the equation. So this one, you don't need to graph it. You don't need to do anything. Just what is the equation that would have vertices at 0, 6 and 0, negative 6, and you know one of the foci, one focus, is at 0, negative 8. That's all they're going to give you is 3 points on the hyperbola, and would you be able to derive the entire equation of that hyperbola given just that information? And then finally in 52, if you look, they've given us a picture, and from that picture we have to use our detective skills and what we know about the hyperbola to pull this information back and ultimately find its equation. So those are the three that I'm going to do, but here's what I want to show you. 42, I'm going to have to complete the square to finish that, and all of these down here take completing the square. This one is completing the square, this one is, this one, all of them that are written without the parentheses and equal to 1 have to be manipulated somehow. And so if I do 42, you should be able to do any of those two, and at least that one right there. So I'm going to do 42, 46, and 52. In addition to that, since up here it says find the equations of the asymptotes, I showed that in the last video, but I'm going to do it again for these, at least for one of them. I will do it. And in this one, it just says put it in standard form, and so the completing the square part on that, when I do it in 42, we'll show you how to complete the square for those problems and have it in standard form. So without further ado, let's move on to this. So here is my first problem. And on this, notice I do have an x squared, but it has an x term. But I'm missing something. And so remember, whenever we had x squared plus bx, we could add something and complete the square on it. So I'm going to work on that. And then here's the y squared and the y stuff. So I will work on that some. And then this 4, though, I'm going to take to the other side. So I'm going to do a few things. Out of these two terms, I'm going to pull a 16. And so I'm going to say we have 16 and then x squared plus, if I divide 64 by 16, it's 4. So plus 4x plus blank. That's going to be for my completing the square. And all I've done is that right there. Now out of this, I can pull a negative 4 out. So I'm going to pull a negative 4, and then I would have y squared plus 2y plus blank. And that's because divide that by negative 4, and a negative divided by negative is positive. And remember I said I'm going to add that 4 to the other side, so now that 4 is there. But here's the deal, I added 2 things to the left side, so I must add those 2 things to the right side. Now is where it's easy. Half of that is 2. Square it, it's 4. Half of that is 1. Square it, it's 1. Most people then would think if I added 4 there, I add 4 there, and if I added 1 there, I add 1 there. And some of the time they would be right, but not this time. Here's why. even though it looks like I only added 4, I really added 16 times 4. And 16 times 4 is 64. So I added 64 in that spot right there. And this other one looks like I added 1, but when I distribute that -4, I've really added a -4 or taken away 4, even though it looks like I added right there. I have in fact taken away 4. So I'm going to have to add a -4 on there. Cool thing happens, we have 4 and -4, those go away. So, and now from our work with the +2 and the +1, this is real easy. It's 16, and I have x plus 2 squared minus 4 y plus 1 squared equals, and since those two dropped off, it's 64. Now, for a hyperbola, we have to have it equal to 1 on the other side. And so I'm going to divide this by 64, hence I'll do it here, and I will need to do it there also. So I'm going to divide by 64, divide by 64, divide by 64, and here 16 goes into 64 4 times, so I'm going to get x plus 2 squared over 4 minus 4 goes into 64 16 times, so I'm going to get y plus 1 squared over 16 equals 1. On this one, I will take it farther and do all of the asymptotes and the vertices, and we'll do the box and the asymptotes, and we'll find the equation of the asymptotes and all of that. But I want to show you something kind of cool first. So here is that kind of cool thing first. So I'm going to delete all of that stuff, and I'm just having this on here right now so that I can type what I need to into this. So the original equation was 16x squared plus 64x minus 4y squared minus 8y. Hold on, Katie. Let me do that over again. 16x squared plus 64x minus 4y squared minus 8y minus 4 equals 0. So there is that graph. Now right below it, I'm going to say, and now I'm going to put this piece. So I'm going to enter that and see, do they in fact lay on top of each other? And so on that one, I have parentheses x plus 2 parentheses squared divided by 4, get out of the bottom, minus parentheses y plus 1 parentheses squared divided by 16, get out of there, equals 1. And here, if I turn these on and off, you can see the green one and the purple one do in fact lay perfectly on top of each other. So what does that do? All that does for you is shows you how to take it from, it's been expanded, and so somebody foiled these out and foiled this out and cleared the denominator, and they kind of wrecked it from the easy way, because this is easy to see. It's centered at -2, -1. We're going to do all that in just a second. But completing the square will change it from kind of this mess into this very clearly written hyperbola in there. And in your homework, that is how you would do any and all of these two, this one, and those right there. So all of those follow that exact same thing. Complete the square. Make sure you track what you're really adding to both sides. And as long as you do that, you shouldn't have any problem. Okay. Now that we've done that, though, let's actually graph it and see what we have going for us. So here is my graph. First thing I know is this. It's going to be centered at -2 and -1. And so if I go left 2 and down 1, that should be my center right there. Now, if you followed the video last time, we look under the x. There's a 4 there. I square root that. That'll be a 2. That tells me how far to go left and right. Well, if I go right 2, I'm right there. And if I go left 2, I'm right there. After that, we look at what's under the y. It's 16. We square root that, and it's 4. So I'm going to go up 4, and I'm going to go down 4. Now all those serve to do is create this rectangular box. And out of that box, I don't really care about anything because I'm going to put these lines in that go through the corners and the center. And then I have one more important thing. I ask myself, who gets the negative and y gets the negative? That means the bottleneck runs in the y direction. Since that's the case, it's going to go like this. That means that is a vertex and that is a vertex. And so I tend to darken them in a little bit more to show that they're there. And I know those coordinates because from -2, -1, if I went left 2, I'm at -4, -1. And if I went right 2, I'm at 0, -1. So those are the vertices right there. Then the covertices, you can do this if you went up 4, you're at -2, 3. And if you went down 4, you're at -2, -5. So those would be the covertices in that case. We can sketch this in right here and right here. And then like I told you before, to get the equation of the asymptotes for this, now I'm going to zoom in here a little bit because I'm going to write a little bit smaller so I don't run out of room and I don't have to erase anything. What I do is this. I say, okay, here's where I started, and I know that point. That point is -2, -1. And so what did I do from there? I dropped 4, and I ran 2. If I'm looking at this line here, a drop of 4 and a run of 2, that's a slope of -2. So if I dropped 4, ran 2, that's a slope of -2. So using y minus y1 equals mx minus x1 point slope, once I have a slope, which I just said drop 4, run 2, I've got the slope. And once I have a point, it's the center, it's -2, -1. I can feed it in here and I've got the equation of a tangent line. So, or not a tangent line, an asymptote, sorry. So I have y minus y1, that's minus -1, so that's +1, equals m, we said was -2, and an x minus -2, that's going to be x plus 2. If I subtract the 1, I get -2 x plus 2 minus 1. So, and the other slope would be positive, so the only thing that changes there is that 2 becomes a positive 2 from -2, and that's evidenced by, if we're on this line, we rose 4 and ran 2, so a rise of 4 and a run of 2 gives you a slope of 2. So we have -2 parentheses x plus 2 minus 1. Okay, so -2 parentheses x plus 2 parentheses minus 1. That should run perfectly asymptotic to that piece. Then if I say 2 parentheses x plus 2 parentheses minus 1, that is asymptotic also. So there are the two equations of the asymptotes in that case, and I didn't need any formula. Notice I haven't done anything out of the book. Everything here is just looking at this, figuring out centers, figuring out left, rights, and up, downs, figuring out which way the bottleneck goes, and all of that is just right there in your face once you have it in standard form for you. So the other the other asymptote is 2 parentheses x plus 2 minus 1. And now the final thing, if it asked for the foci, here's where we need that one piece I told you that was important. C squared equals a squared plus b squared. So in this case, For a hyperbola, the a is always the positive value, but it doesn't matter. 4 plus 16 is 20, and so c squared would be 20, because that's 4 and that's 16. So then c is root 20. So then what I would do is I would go from here left by root 20 and right by root 20, and those would be my values of my foci. So to illustrate that, then I'm going to say this. The foci is, where was I at? -2, but I need to go left root 20 and then stay at -1, and then -2 and go right root 20 and then stay at -1. So if I put that on this graph, -2 minus root 20, get out of there, comma, -1, and -2 plus root 20, comma, -1. Those are the two foci right there for that piece. And that's everything that you can glean from it. If you need to know how long the transverse axis is and that stuff, you can just add it up. You know we went left and right 2, so it's a total of 4, so the length is 4. And one of them's the width of the box, the other one's the length of the box, and all of that stuff is right there. So that one, again, just to be clear, the directions just said go from here to here and then stop. What I did then was said, well, we can get the center, and we can get the vertices, and we can get the covertices, and we can get the asymptotes, and we can figure out the C, which gives us the foci, and ultimately we can draw a pretty darn good looking graph. All of that was extra though, but I'm showing it to you because in these problems it asks you to identify the vertices and foci and then do the asymptotes, so you got to do that in here. In these, it just says find the equations of the asymptotes. So you don't care about the center and vertices and the graph, and that all you care about is the asymptotes. In here, it's sketch a graph, labeling vertices and foci. So in that, you would want to do what we had here in Desmos and label those, again, -2, comma, -1. There's the center. If I went left 2, we were at -4, comma, -1. And we were at 0, comma, -1. Those were the vertices right there. So I have put all of those in, and that's what the directions would want right here, because you label the vertices. In there, the vertices were the black and the red one right there, and the foci were the green and the blue ones. So that one you would do for these problems and these over here ultimately, but it doesn't ask about the asymptotes or anything like that. It just says sketch a graph, and so but label those. So you have to know the values for them to be able to label them. Okay, so then let's do something like this. So in this problem, it really came from, and I already told you this, it's problem 46. So it says for the following exercises, given information about the graphs of the hyperbola, find its equation. So given that it has vertices at 0, 6, and 0, -6, and we know one foci is at -0, -8, how can I get the equation for that? Well, here's what we're going to do. So I wrote down just the key points, that we have vertices at 0, 6, and 0, -6, and the foci at 0, -8. What I am going to do then is just draw a graph and say, okay, well, here's -6, and here's 6, and those are vertices. If those are vertices, I already know it goes like this. Since we went left 6 and right 6, I know it's centered at 0, 0 also. And so since it goes like this, and it's centered at 0, 0, I know it should be an x squared over something minus y squared over something equals 1. So I already have that information just from kind of plotting that and being like, oh, if those are vertices, then it's going to go like that. And if it opens in the y direction, the y should have the negative. And then here's another thing I know is how far did I go left and right? I went left and right 6. Well, what would make me go left and right 6? Would do that if I saw 36 under the x. So there I've got one of those values. Now I need to know what's the deal here with this foci at 0, -8. Until you remember that foci deals with c. And so that means c squared is supposed to be a squared plus b squared. Well, the a squared is 36 right there, so I can put a 36 in there. C squared, if I square -8, I'm going to get 64. And then plus b squared. And if I take away 36 from both sides, I get b squared is 28. So I'm going to put a 28 right there on the bottom. And now I'm going to see if that equation fits this description. Okay, so let's do that now. In here, I'm going to delete all this stuff. And I'm actually going to, whoops. Okay, here we go. So my equation is x squared divided by 36 minus y squared divided by 28 equals 1. And they told me that 0, -6 was on there, and 0, 6 was on there. Oh, I did it the wrong way. Sorry. So let me change this slightly. This is 6, 0, and -6, 0. So I read it the wrong way at first, and I had it written down backwards in my head. So in this case, we do go left and right 6. I'm going to do the other one after this. So if this is the case, then we should be at 6, 0, and -6, 0. And there's those two pieces. And then at -8, 0, so if I put -8, 0 in there, there is that foci. And so you can see that would fit that information. So let me go back here now and fix this. It's not much difference except this. So it was 0, 6, and 0, -6. So what that means is we're going to go down 6 and put a dot, and up 6 and put a dot. And since those are vertices now I know it runs like this. So that means it should be y squared over minus x squared over equals 1. Since I went up and down 6, I would have seen a 36 there. The same information would hold, and that would be a 28. And so if I took this and all I did to it was change that to a plus and change that to a minus and made these points 0, 6, zero. Oh, 0, then hold up. I can't just do that. So I have to change these numbers. 36, and that has to change to a 28. So now if I go 0, 6 and 0, -6, 0, -6, there those are. And if we go 0, -8, then there's that foci in there. The way you do it, it does just round, and it winds up just changing those values in there. The last one then is this one, and given the graph, can you pull the equation out of this? So here's what we're going to do. I see the center's at 1, 1, and I see that it opens in the y direction, which means to center it at 1, it should be an x minus 1 squared over something minus a y minus 1 squared over something equals 1. And that will give me a center of 1, 1, and so that makes sense with that right there. Now I look and I see that, the vertices, I went left root 2 and right root 2. Well, what would make me go left root 2 and right root 2? It would be if I saw a 2 under the x, because then I'd say, well, what's under the x is a 2. The square root of that is square root 2. So we're going to go left root 2 and right root 2. So we have that. Now this is my b squared down here. So I know c squared, and c squared is what I get in the foci. And the foci, it looks like I went left and right by root 5. That's c. So c squared then should be 5. And c squared should equal a squared, which is 2, plus b squared. That gives me b squared equals 3. And so I can put a 3 under there. And if I do that, I'm going to pull this up, and I'm going to say x minus 1 parentheses squared divided by 2 minus y minus 1 squared divided by 3 equals 1. And if I put 1, 1 in there, there's the center. And if I put 1 minus square root 2, negative 1, or comma 1, and 1 plus root 2, 1, you can see I am putting in the center and those points are exactly these points in here, and they're matching up and lining up exactly where they're supposed to. So that tells me that this is the correct equation, and that's all it asked for. So if I needed to, I could get the center out there. I could get how far left and right, how far up and down. We could get the asymptotes. We could get everything we need from this. And so that's it for that. I will make one more video for you guys tomorrow on everything for parabolas, but hang in there, keep doing your best. I'm certainly proud of you, and we'll talk soon. All right? Bye-bye.